Hey folks, welcome. Welcome to our next AKS community meeting. Good to have everybody here. I am going to get things started. Have to kind of remove all my videos and so forth. But yes, so today's session, we're excited to put on a session about the Notary Project and really securing the supply chain. Something I think is going to be super interesting. So we have special guests to come on and talk about that. One thing I wanted to mention, kind of getting into a cadence of doing this a couple times a month. In some cases, I'll have actual announcements and things to talk about, especially as we head into the Ignite and KubeCon season. There will be a lot to talk about. What I've noticed is a lot of people join and watch these on the recordings, and that's great. The live sessions, obviously, it's hard for people to really join these kinds of things. I have tons of live sessions I'm super interested in, and I often don't make it to the kind of live stream of them. But I did get a lot of feedback that people want to be able to have more of an interactive kind of session. And so I have plans to do kind of like ask me anything sessions with some of our key engineering leaders and things like that. And that requires people to be on here kind of asking questions live. I will probably take some questions ahead of time via Twitter or whatever it may be. But when we do one of those kind of sessions in the future, if you're listening to the recording, try to join those live and you'll have a good chance to kind of have an interactive discussion, at least via YouTube, to do that. So let's go ahead and get started. Today's community meeting, we're going to be talking, like I said, about the Notary Project. We'll have Tati and Sajay. I'll let them introduce themselves here in a moment, doing some of the talk and some of the demos. And so very excited to go ahead and get this started. So I'm going to add them to the screen here. Give me 1 second. Hey folks, and I'll have you guys do introductions first, if you don't mind. Go ahead and you can start with that. Start, Tati, if you'd like.
Sure. Thanks, Brian. I'm Todi Mladenov. I'm a principal product manager on the Azure Cloud Native and Ecosystem team, and I'm one of the maintainers of Notary Project from Microsoft side.
Hi, I'm Sajay Anthony. I'm an engineering manager in ACR. I work with Toddy and Brian and other folks on container secure supply chain as well as container distribution.
Yep, awesome. Good to have you both here. Yeah, Sajay and I have worked together some of the early days of AKS when we were just building our Kubernetes service and our container registry technology. So good to be presenting here together. And this is one of those topics too. I feel like most customers that have been doing Kubernetes for a while, they probably think they're good at container security because they have some sort of vulnerability scanner tool. There's great technology out there that can just scan images for vulnerabilities and ensure that that's taken care of. And I would imagine most companies for meaningful workloads, they've checked that box. So I'm kind of curious today, there's obviously things we should be doing beyond that. And that's really, I think, one of the key aspects of this. But I'll let you kind of fill in that gap. But is that what you've seen as well? Just kind of talking to customers as you've been building this?
Yeah. We've seen mostly actually customers concentrate on the vulnerability scanning and patching container images. And right now it's like Wild West. Like some people patch very rigorously. Some people just go pull things from Docker Hub. We can talk about that at length. So I don't think the 20-30 minutes that we have will be enough to discuss all the scenarios there. But yep.
It's not really a new problem. I mean, think about like it's just container images is just one place we've got to do this. We got all kinds of package managers and code and things like that. So it's certainly something that hopefully companies are staying on top of, and certainly one of the big things that people address when they're going to Kubernetes. So, Tati, I'll go ahead and put your screen up there and let you get started, and I'll probably pop off camera, but I'll be there on the chat. If we get questions in the chat somewhere towards the end, we'll just put them up on screen and let you answer. So I'm gonna turn it over to you.
And feel free to also ask any questions. So Sajay and I have been kind of working on this for quite a while already, and we may think that we have answered every question, but we quite often get questions like, okay, that's a pretty good question. We need to think about that. But yeah, the first thing that I would like to go is to really talk about the supply chain for containers. And the way that we look at that is that we split it in a couple of stages, right? So when you think about the first thing that you do when you work with containers is most probably you go to Docker Hub and say from Ubuntu or from Debian or from Python, this is the first statement that you get in your Docker file. What that means is that this container image that is used for your actually build is pulled directly from this external registry. Most often that is Docker Hub, but of course we have Google Artifact Registry, Quay, ECR Public, NVIDIA, and so on. So this is kind of what we consider as the first stage of container secure supply chain. We've seen customers also go over a process that they, instead letting their engineers pull from Docker Hub or external registry directly, they import them internally and they catalog them. And what you mentioned, actually, they do a scan there. So before they allow this base container image to be used internally by the engineering teams, they import it inside, store it in their, they call it a golden registry. They do scans, and mainly that's what they concentrate on. And after that, they allow teams to build. And in the build pipelines, we have all kind of build pipelines, GitHub, GitLab, Azure DevOps, Circle CI, Jenkins, whatever you know. But on the build pipeline, there are very little enforcement on actually whether that image is authentic or whether it actually comes from a trusted registry or from outside. So this is something that enterprises are still kind of trying to figure out. The next stage that we look at is the so-called deploy stage. So once you build container image with your application, you push it into some registry, and then eventually you have some continuous scanning on this registry, because as we all know, new vulnerabilities are discovered all the time. So you need to constantly refresh that information. So one of the things that we very often do or continue to do is we think that once we scan it once, and that is like, okay, now the image is all good and we can continue using it, right? The way that we think about is like information about this image changes on a daily basis, whether new vulnerabilities are discovered, new malware is discovered, some licenses change for software in the image, some libraries discover that actually it's malicious and something like this. The life cycle of the image changes. So we do not think that actually the information about the container images is static. And by that means any kind of software. So continuous scanning, continuous updates of those images in every registry that you have throughout the pipeline is something that we consider quite important. And of course, when you think about the run side, we have a couple of things that we are thinking there. Before you deploy, you need to verify whether the latest state of this image is really what you expect it to be. We have a couple of technologies there that we are working. They are open source, like Gatekeeper, Ratify. You can think about Kyverno is also admission controller that can do those checks and say, well, is that image vulnerability free? Does the licenses actually that I approve for my enterprise match, or is the image signed, and so on? So those are kind of the 5 stages that we look at for secure supply chain for containers. And of course, one important part is like, when the image moves through those 5 stages, how do you ensure authenticity and integrity of the image? How do you make sure that like the image that you acquired from, let's say, Docker Hub is produced by the publisher to Docker Hub that you expect to produce it? So if there is no signature, I will just trust that Docker Hub is serving the right image. But we've seen very often that actually either Docker Hub gets attacked with typo squatting attacks, or some images get actually replaced. So that is not enough guarantee that when I pull from, let's say, Docker Hub or some public registry, the image is authentic. But even inside your enterprise, right, between each one of those stages, because those are different systems, is how do I make sure that the previous stage really kind of produce that image that I expect in the next stage, and how do I trust it? So this is where kind of Notary Project comes into place, ensuring the authenticity and integrity of the container images between the different stages. So Sajay, you want to add something here?
Yeah, I think it's probably worth mentioning that is the scope only to signatures? What else can we do with container supply chain? I think that's maybe a point worth touching upon.
It's not only signatures. So signatures is important to ensure that actually what I, for example, produce doesn't actually can be tampered with. But adding attestations, for example, at each individual stage, and say, look, I, for example, built this image with this build context, and I add attestation that describes, for example, the build context in the build stage. And also I sign that, so nobody can go and actually modify this attestation, because you can think that, for example, the attack can be, well, I build it with this build context, but somebody goes and changes some of the fields to trick the next, for example, consumer of this image with information. One of the very often scenarios that we discuss is take, for example, you scan your vulnerability for vulnerabilities every day, right? Coming back to the scenario that Brian was explaining. And you rely that there is a vulnerability scan every day, right? But take, for example, I go and take a scan from 5 days ago when the image was clean, and just push it and say, okay, this is the latest. I just change the date and say, this is the latest, which means I invalidate the latest scan that, for example, has severe vulnerabilities, and I trick you to use a scan that is outdated. If I do that, for example, and if I don't sign let's say, the vulnerability scans, I will be able to easily trick you. But if I sign it, so any kind of changes there and the relationship between the image and the metadata, then it will be easily detectable to say, well, now I can actually detect that this is not the valid scan that I'm expecting.
So maybe the point you're alluding to is that you have a scan, but you also have a authentic scan that is signed in some way. How about things like SBOM and other things? How do you want to think about them?
In the same way, like, for example, if I have, for example, the SBOM generated at my build stage, right? And I can, for example, sign this SBOM, and also I can put an attestation to say this SBOM is generated during the build as part of the, let's say, the provenance of this image. Signing it and adding the attestation will ensure that actually I have higher level security than just adding the SBOM to the image, right? SBOM can be replaced, can be tampered with. I can go and, for example, change information in the SBOM to, let's say, change a version of software that is included in the image.
So time check.
What are your thoughts? I think you are going somewhere with those questions. I am trying to answer them, but maybe you have something in mind that you want to share.
No, I just want to do a time check. Maybe Brian can help us figure out. I'm guessing there's also excitement to get to the demos as well.
Yeah, it's up to you. Yeah, demos are always the most fun part, in my opinion. So yeah, let's see it.
Yeah, let me just quickly say what Notary Project is. The way that actually we define the project is, this is a standards-based specification and tooling for securing the software supply chain. So signatures and are just kind of the beginning. We are looking at much more like attestation, some standard metadata that you can ensure that throughout all these stages, you have necessary information to actually track what is happening in the supply chain. And the one important thing is the specification for portable signatures. One of the things that really we spend a lot of time on is to make sure that when I sign something in one registry, I can take the image and the signature, just copy them in another registry and make sure that I still can verify that. And of course, we have a reference implementation in the form of notation CLI and Golang libraries that can be used by teams to sign not only images, but any kind of OCI artifact, and also verify those. So let's take a look at the, actually I have a quick demo. I can demo how we can sign using a test certificate that is used only for learning how notation works. And also I can sign with the certificates saved in a KMS, where actually the key doesn't leave the KMS. Starting with this, so I'll set a couple of environment variables. So I have a application image, which is my Flask sample application, and I have a test image, which is the net monitor one. So here I have a couple of things. So first, I have notation version 1.0.0. So we had our major release last month. I also have a plugin that is actually for notation. So notation is the CLI that actually we use for signing and verification. But the CLI can have different plugins. So I can create a plugins for, let's say, Azure Key Vault. As you can see, I'll use the Azure Key Vault plugin, but there is a plugin for AWS Signer, and we are also working on a plugin for HashiCorp Vault. So it has a plugin architecture, so different KMS vendors can create plugins. And I have a single tag for the application image and a single tag for my test image. And as you can see, I don't have any keys yet. So the first thing I'm going to do is I will just create a test key that will be stored on my local machine. And I will just go and sign with that. So let's see through the steps that are going here. So the first thing is I generate test key and certificate with the notation cert generate test command. That automatically creates the Wabbit network IO key, which is the test key name, and also creates a corresponding certificate. So this process should be used only for testing purposes. So if you want to learn how the notation CLI is working, this is the easiest way to do it, and it's very simple to actually generate those. It's not very secure because, as I said, the key is stored on my local machine, as you can see. So the key is stored in my application support folder. Once I actually run that command, everything is set, and I can just go and say notation sign, signature format. I can choose between two signatures formats. One is COSI, the other one is JWS. And I can just point to my test image. So, and that's about it. So that is everything I need to do to actually go and sign a container image. So as you can see, my container image that is stored in GHCR, the .NET Monitor one, has a Notary Project signature. Okay. As I mentioned, this is kind of really, if you want to go and kick the tires of the tool, you can actually do this. But now a more advanced scenario where actually the key is stored in a KMS, which is much more secure way to do it, is our next actually scenario. So I'll demo this with Azure Key Vault. A couple of things here. So I need the key vault, the name of the remote key. So those are kind of Azure Key Vault specific concepts here. So I will retrieve the key from Azure Key Vault as a name, and I will add it to my list of keys that I can use for signing. And as you can see here, the key is not stored on my local machine. So there is no local path for this key. So the key is stored in Azure Key Vault, and we access it remotely. So now if I do a notation sign, I can actually sign my application image, and I can see that this application image is signed with the key that is stored in Azure Key Vault. So once you actually set up the key, the process for signing the image is exactly the same. So this is a very simple and easy way to actually go and check how you can sign container images. Thoughts, questions, Sajay?
Yeah, it's important to call out that the signing actually happens remote. So there's no signing locally, and the plugin is able to kind of issue a key vault request to sign, and remote key management services, AWS, Azure, anything else kind of like can offload the signing to a remote service. I think that's a very important aspect here.
Yep.
So also, I mean, if I'm building this into a pipeline, I'm obviously got some kind of CI/CD process. This obviously ends up happening somewhere as a part of that build process. So, I mean, I assume that's easy enough to integrate if I'm using, say, GitHub Actions or something.
Yeah, we actually have a GitHub action that you can use. So it's available on the marketplace. I think that was released this week.
Yesterday.
You can go search.
Wonderful timing,
yesterday.
Right? Wonderful timing.
Yeah. So you can go and actually use this GitHub action and sign it, and it's very easy to do that. Yep. So that was kind of my part of the demo. I think Sajay has a demo how this can be used on the consumer side. So now that I have actually signed the image, how do I verify the signature and before I, for example, deploy it on Kubernetes?
Yeah, I'm sure that's what anyone would be thinking. How do I do the other side of this? So let me add your screen here.
Sure. Before I get to the demo, maybe I can give some context. Notation does have a way to verify the signatures using the CLI. So if you want to test, hey, whether I've signed it correctly, whether can I run verify and things like that. It also has a bunch of trust policy capabilities that you can use to write a trust policy, scope certain images to certain certificates and things like that. So it has a bunch of things in Notation that will help you pretty much validate everything without having to even go to Kubernetes. One of the interesting concepts is that as we kind of like looked at the ecosystem of cloud native artifacts and where you want to verify them, Kubernetes became a natural choice. And how do you kind of like take it to it? So with that in mind, we kind of incubated Ratify, and Ratify is a framework. We can kind of think of it as a verification framework with like capabilities to do artifact ratification. You can use Notation as an example. So why I was alluding to whether it's just signatures is maybe you want to validate an SBOM, whether you want to validate saying that whether this particular SBOM has a license that is okay to run in your organization. You want to check some attestation. You want to probably go ahead and validate whether a vulnerability report is of a particular type and things like that. So there's a different set of capabilities. But for today's demo, I'll keep it simple and maybe just zone in on how do you use this with a signature that is produced by Notation, and we can take it from there. But I'll talk about some extensibilities and features of things that we're doing for Ratify as well. So here I have a kind cluster set up just to keep it very simple to run. And I have Ratify previously set up within the Gatekeeper namespace. So we can just take a look at what's in the deployment under the Gatekeeper namespace, and you see that I have the Ratify pod that's running here. The important aspect here is that Ratify is using Gatekeeper's external data feature to communicate, and it's kind of coupled with a very strong dependency of Gatekeeper in this specific scenario. I think the next thing is how do these signatures actually look inside the registry? So I have an unsigned image. It's got nothing. So you can see that if I look at the reference API of OCI, which tells you if things are attached to this image, you're not going to see much in this one. So this is an unsigned image. Just hold on to this thought. Now we're going to go back to what Toddy did, which is I have an image, I have signed it, and how does the signature actually look, right? So if you kind of squint at it, you have the image. The image is backed by a SHA, which is kind of starting with 5AA. It has a Notary Project signature, and the SHA of that specific manifest of the signature is shown in this as well. And there are some annotations with the signature. You can see that this is the thumbprint. This is when it was created. The next thing that we want to do is let's go ahead and try to run this image. Now, all things equal, if you run a signed image, it should pass. So I think let's go ahead and run the signed image, right? And hopefully nothing bad happens if the demo gods are all going to be kind to me. All right, so you can see that this demo pod got created. The interesting aspect, I think, is what happens when you actually run an unsigned image. So Ratify here has been configured to look at a specific key, a notation certificate, and that should stop your server from actually executing this pod. And so you can see that the admission webhook has failed. Now, it's not telling you exactly why it failed. So I think that's the next step about this. Like, let's go ahead and introspect, like, why did this, signature executing this unsigned image fail? So we can look at the logs, and I think the screen is kind of like a little zoomed in. But let's kind of take a look at this specific image that failed. It is saying that there were no referrers. And the point here is that this image did not even have a signature. So even if it did have a signature, the next step would be, was it signed by something that you believe is authentic, right? Like, what is the certificate that it used? And so that, let me see if I can get to that portion of the log. So this is the previous one that we first ran. So you can see in this one that the signature verification was successful, and some extension information like who was the issuer and exactly those kind of things that you can introspect. It's using a trust policy in the back to kind of like stitch these pieces of information together to say that for this specific image, what do I need to use to kind of like trust this? And that is a notation trust policy. So that's the high level things. Any questions on this before I kind of move on?
Maybe one thing, so the way you can think about this as a scenario is like, for example, you may want to actually enable certain images to be run on certain environment, right? And you can, for example, restrict whether this signature is accepted only on the test environment or only on the production environment. So, for example, you don't want to run on your production environment images that are signed by Toddy as a developer, right? So you want to run images that are only signed by the release pipeline, and that may be a different signature.
Cool. So this
Go ahead, Sajid.
Yeah, this is very simple. We're using a certificate to kind of bind it. I think in the interest of time, we're not going to get into how do you configure one specific image bound by a certain key. We kind of think of it as a trust policy in notation, and there's a notion of scopes. And the registry scopes will tell you that I can install Nginx signed by my base registry or Docker, provided it has a signature of some kind, or I can even skip verification for certain images. Please don't do that, but doable. If you want to keep your what you're running as authentic in some way. But that's the integration. The other small thing I probably want to bring up is what's the future of Ratify, right? So maybe if I can, let me see if I can get this up. So a couple of points maybe wanted to touch upon, right? Like Ratify has a notion of plugins, right? You can create extensible verifiers. So we're looking at how do you verify SBOM? How do we verify cosign signatures? How do you verify vulnerability reports or attestation? So the notion is that you have plugins that Ratify can use, and a notation is a plugin. It's a built-in plugin for Ratify. That's pretty much how it works. The other thing I think we want to talk about is the future of Ratify, which is there's an experimental feature for high availability, because if you're going to validate, I don't know, a deployment with like 500 pods or thousands of pods, the number of requests and things like that would be pretty high. So how do we ensure that it's got a good backing for cache and avoiding what you say, a large number of requests to your registries? As you know, registries have throttling limits. So how do you kind of make this optimal? The other one is there's extensibility is already plugged in for AWS and Azure already. So that's another thing that I didn't dive into. I just wanted to show how you can, as a developer, get started, quickly set this up. And finally, you can do things like, this is an experimental feature where you can actually validate your SPDX and Ratify. And lastly, not in the docs, but there was a recent PR merged into Continuity that enables verification at the Continuity level through a transfer plugin implementation. And we're looking at how to kind of see if Ratify can be invoked directly from Continuity without even depending on your environment, like if it's a non-Kubernetes environment. And I think that's the high level that I had to cover. Anything else, Toddy, Brian, do you want to talk about, or I can hand it back to you?
I guess I would just highlight, it just, you can tell me if I'm wrong. I mean, obviously you're mentioning a number of different kind of open source tools, and I see AWS and different clouds on there. I mean, these are straight up upstream tools that I can grab and run in my Kubernetes environment, wherever it may be. Obviously, we try to take those tools and build them into AKS with add-ons and so forth. But really, these are just open source tools available for anyone, correct?
Right. Ratify has, we kept it in such a way that the AWS contributions were done by the AWS folks. They looked at the IAM policies. How do you kind of validate it and stitch it together? So those templates and those are kind of done with their help. The Azure ones obviously were done by folks on my team. And so we kind of you worked with the AKS team to enable this as using the workload identity and things like that. So there's goodness in how these are coming together. But you don't need any of these. You can run this on your Kubernetes cluster, raw Kubernetes cluster, and use notation with your keys that you set up in your environment, totally locked down, no requirements. So we wanted to start with the notion that Ratify is fully open source. They're providers like how Kubernetes has cloud providers, and we kind of attach them as needed depending on your scenario and where you run.
That's good. I feel like we can. Oh, sorry, real quick. I just feel like we consistently hear that feedback from customers to make sure that we're building features into AKS that are built from upstream tools. Like if they want to do GitOps, they like that we're using Flux in our solution, or at least they like that we're using something upstream. Sometimes they want to see a different tool, but it's just super important that we make sure that they have that portability that they get out of Kubernetes in the first place, along with all the kind of tools. Sorry, go ahead, Toddy.
Yeah, what I wanted to mention is that you can think of, for example, we have many customers that say, look, I also have something on-premise that is working. So how can I actually transfer workloads between on-premise and Azure? That is one scenario. And if you have both Ratify working on the on-premise cluster and in AKS, right? These type of policies are much easier to manage than if you have two kind of not consistent environments. And also, there are customers that implement multi-cloud environments, like they may want to actually have workloads running on AWS and Azure. Now, when you have consistent admission controller and external data provider, they don't need to do too much work for each one of those environments.
And to kind of state the obvious, that is why we went behind Gatekeeper, right? Ratify is an extension to Gatekeeper. There's a lot of customers who are already exploring Gatekeeper policies, and kind of pivoting into that ecosystem was the idea, rather than inventing yet another way to do admissions and things like that. So I think it's important that, Brian, you're mentioning that how do we stitch these things together? Notary Project is under CNCF, and we've done all the work to kind of enable these signatures as a specification, take it to different formats, and similarly kind of Ratify stitches into that project rather than bring its own signature format or things like that. So
one question, are you folks going to be at KubeCon this year? I feel like a lot of people are going to want to ask about this. I think obviously the CNCF connection makes it kind of an obvious place. Is your team, or at least you particularly, going to be there?
I most probably will be at KubeCon, and we'll have a lot of folks that are familiar with these technologies that will be there. So quite a few people from the team will be available. If there are any questions, we'll be happy to. And I think there will be a few demos at KubeCon as well as sessions that will talk about that.
I'll be there in spirit with Toddy fronting the whole work.
Yeah, awesome. Yeah, I expect to be there. I certainly hope people come by the Microsoft or booth and ask questions about it. Yeah, this is super helpful to actually watch it all. Even though I know the basis of a lot of this, it was actually super helpful for me to see it in action. So very cool. Other thoughts and questions? I mean, I'd have a wrap up question for you, but just I want to make sure you're hitting everything that you wanted to.
No, I'm good. We are over time, so
yeah, I guess,
we're excited to get feedback. I think that's what will help the most. If you have issues, please let us know. Please ping us. We're listening as much as possible.
Yeah, absolutely. And I'll put some links that related to all of this stuff in the video description. I guess just one final question for you. I mean, where are we headed with this from here? I saw, 1.0 releases. That's always super exciting. What are the big sort of things that we need to accomplish in the next 6 or 9 months?
Sorry, you want to take that? Leave it to the PM.
Yeah, so from a Notary Project point of view, we are looking at kind of expanding these to, as I mentioned, we need right now the first release, mainly notation can sign OCI artifacts. So the next big thing for us is really signing arbitrary blobs, because certain scenarios you want to actually have the signature before you even push to a registry, or you want to have a signature on some artifact that even doesn't end up in the registry. That's one big thing. The other big thing that we are looking at is really improving the experience of signing everything in a contained environment. So when you think about like you produce your, let's say, image on your build machine, you want to sign it even before you push it to the registry, because the registry may actually be compromised, or you don't own the registry, right? So you don't want to push it to Docker Hub, and by the time you do a signature, actually this gets kind of replaced. We are also looking into the different types of attestations that we can work and provide some attestation framework, which of course will again require signatures, because when you do attestation, you need to sign it to kind of make sure that this attestation doesn't change after that. That's from kind of a Notary Project point of view. I think Sajay went through the Ratify and what do we expect in the future from Ratify. But Sajay, you want to add something?
Yeah, no, you covered most of it. I think signing arbitrary data, how do you sign attestations, how do you verify this in different environments is probably going to be one. Signing extensibility. I think the other ones that we're looking at definitely is how do we take this entire supply chain, like secure it from end to end, right? How do you acquire it? I think we'll have some information for Toddy's definitely has some cool demos for KubeCon that he's preparing as well.
Awesome. Yep. Can't wait to see that. Yeah. So thanks very much for the time here. This was great. I actually loved this session. I loved how you had real demos, and there was actually kind of a connection between both the demos. It's super appreciated. I think this audience wants to see the real thing and see things happening in action. So again, thank you to both of you for being here. Appreciate it a ton.
Yeah. Thanks, Brian, for inviting us. Yeah.
Yep. Absolutely. I'm going to let you go. I'll wrap up. I'll say a couple comments that people probably won't continue to listen to the video to hear, but I'm going to say it anyway. So thanks again, folks. Yep.
Yep.
So with that, I will go ahead and wrap up. I'd like to just put up at least this as a final sort of thank you for joining, whether you're joining on the recording or the live stream. Good to have you here. You can see how to communicate with the AKS community here and my Twitter as well. As always, I'm dying to hear from folks about what you'd like to see on this kind of channel and what kind of topics you want to see. So please bring that to us, and we will do our best to bring it to you. So with that, I'll wrap up. Hope you folks have a great day wherever you are in the world. Thank you.